Hi, I'm Brandon Royal, Solution Manager and Technical Strategist for CICD and Anthos Solutions here at Google Cloud. I'm joined by my colleague, Ben Good, Solution Architect and DevOps Expert, also at Google Cloud. During today's session, we'll discuss some of the common challenges that customers see when it comes to modernizing their CICD, especially around hybrid cloud deployments of that infrastructure. We'll review some of the core principles that we think about when architecting and modernizing CICD solutions with our enterprise customers. And finally, we'll discuss how Anthos can be leveraged within your environment to build more robust, consistent pipelines across not only on-prem as well as hybrid cloud environments, enable those pipelines for not only application configuration, but also policies and configuration, and ultimately help your application teams to deploy code faster. Now, CI/CD is not a new concept. It's been around for at least a decade, and a lot of the tools and practices really haven't changed that much. What has changed quite significantly is the infrastructure surrounding CI/CD. So specifically, we've moved from a more imperative infrastructure where we're describing all the changes that we need to do within our pipelines to more of a declarative infrastructure, not only for our applications, but also our underlying infrastructure and security policies. Now, speaking of security often has a very different operating model from developers and operations, and we see that as a point of friction within a lot of our customers. And then we also are seeing very inconsistent tools between on-premises deployments of CI/CD and cloud deployments. Many of our customers describe that they have one very different set of tools for managing, deploying the test build automation for their cloud-based applications, and a very different one for on-premises. And then we all know there's manual processes that are involved in especially configuration changes across environments. And we find that's a huge issue when creating those inconsistencies, especially between multiple cloud environments. Now, DevOps Research and Assessment, the organization that brings you the state of DevOps report, published some really interesting findings when it comes to DevOps performance. This report has tons and tons of details, but some of the most important parts are DevOps performance is directly correlated with organizational performance. So improving the performance of your CI/CD pipelines, the pace at which you're deploying your code, the time in which it takes you to recover from any service degradation is directly correlated to your organization's performance. Also, the selection of cloud-based tools have a very meaningful impact in your ability to be a high performer within those key DevOps metrics. And then last, and this course isn't going to be surprising to anyone, organizations that are using more slow change management approval processes using standard ticketing-based methods often don't perform as well as those that are using more GitOps-based methods. And that's what we're going to talk a little bit about today. Now, when we think about modernizing CI/CD, we think about these 5 principles. First, we look at security. So security is not only in terms of how we create a secure pipeline, but also how we create very clear separation of duties between developers, operators, and security. And we'll talk specifically about what those responsibilities are. We want to ensure that we're securing the pipeline through vulnerability management and attestation, so we're able to cryptographically sign our images as they go from build to test to deployment. And then we want to manage the entire process using robust access control. Now, we talked a little bit about imperative versus declarative infrastructure. We want to manage all of our configuration, from application configuration down to infrastructure configuration as code. That allows us to have a single auditable source of truth for all of our applications, and also gives us a clean Git-based interface in which we can manage all those configurations. We want to drive automation, of course. That's what CI/CD is all about. But we not only want to look at automating our code deployment process, but also our security policy process. So the way in which we are managing those security configurations across multi-clustered environments is critical to automate as well. And we want to leverage containers wherever possible, not only for the applications, because that was going to provide that isolated, extensible environment, but also for our actual build infrastructure itself. Google has a significant commitment to Kubernetes open source ecosystem, and we want to ensure that we're providing open standards-based interfaces for all of our CI/CD infrastructure, allowing you to leverage the existing investments that you have in place today. So what does that mean? Ultimately, that process of modernizing your CI/CD practices with Anthos is going to help your developers to reduce burden and focus on value-added tasks, developing code and providing it to your customers. It will help you to establish better governance across your entire CI/CD process, and allow you to share those best practices between development teams. So one development team can benefit from the innovation of another. And then finally, we want to provide, and this solution ultimately will help to provide flexibility to deploy those same configurations across cloud environments as well as on-prem environments. So when we think about CI/CD, it's more than just the CI/CD pipelines themselves. CI/CD pipelines are absolutely important in our testing process and our deployment process, but we also want to think about what's below the surface. And very similar to a bridge structure where below the roadway there's all kinds of complexities in managing the structure of the bridge itself, of the roadway itself, we want to think about CI/CD in a very similar way, where the underlying structure is our platform configuration and our management and our ability to manage those configurations across environments, and ultimately to orchestrate and automate the underlying infrastructure that supports our applications and our CI/CD pipelines. The way that we do this is we break down the problem into components. So we talk about this in terms of the CI/CD component taxonomy. These are the major components that anyone needs to think about when they're deploying a CI/CD process. And we want to ensure with this methodology, you're able to leverage existing components that you might have in place already, including things like application observability. You might have robust CD pipelines that you want to continue to use, or maybe even CI pipelines. So this solution allows you to plug in these existing investments and manage them on top of Anthos for that ultimate consistency. When we talk about various stakeholders in the organization, generally we talk about developers, operators, and security. Each one has slightly different goals when it comes to modernizing their approach to CI/CD. The operations teams are here to standardize how application teams are onboarded and how those applications are managed over time. The security team has a new set of challenges. They ultimately need to inject and propagate all of those application policies and configurations across not only one environment, but multiple environments, potentially spread across multiple clouds. And then developers. We talked about developers needing to focus on developing and providing code. So we want to reduce the burden for those developers wherever possible and allow them to provide that value as quickly as possible. One of the ways in which we do that in this solution is to provide standard interfaces. And these are all open standard interfaces that we use in order to plug in those existing components into the Kubernetes ecosystem wherever possible. The first is standard Git-based interfaces. Now, Git allows us to have that Git-based or GitOps-based process, whereby which we are deploying all of our code and configurations directly through Git repositories. The second is container-based images. Ultimately, we can describe our application, but also our infrastructure using standard OCI-based images. And then last, these are all ultimately Kubernetes objects. Anthos provides that Kubernetes platform, and using things like Anthos configuration management, that allows us to manage those Kubernetes manifests across multiple environments. So let's talk a little bit about the workflow. Some of these aspects will seem very familiar to those of you who are already deploying CI/CD workflows within your enterprise environments. The first is the developer workflow. We want to allow our developers to start with their application code repository and use a continuous integration pipeline to build, to test, and ultimately deploy into a staged environment. This pipeline will build our container images and we'll push them into a container registry. Now, next up is our operator. Now, our operator in this case is going to start with not the application code repository, but a different repository specifically designed to share code best practices. Now, this repository will contain all of the shared standards for various applications that might be deployed within the enterprise, and that operator can use inheritance models that we'll talk about here shortly to manage the configuration delta between what's deployed in the developer's application and what's managed in the shared best practices repository. The operator will trigger a pipeline specifically designed for rendering all of the configurations. So using a tool like Customize or like Helm, we can actually take multiple configurations that might be shared across our shared best practices repository and the application repository and render them into fully hydrated manifests in what we call our environment repository. Now, that environment repository is our single source of truth. That's where we can audit all of our configurations. And as you'll see in the demo, we can see all of these specific configurations, even down to the hashes of our images that are deployed in various environments. And then last and certainly not least, our security. They need to use a Anthos configuration management repository, or ACM repository, to manage not only their infrastructure configuration, but also their policies, which will be then propagated to the clusters using Anthos configuration management. Now, as far as the application configurations are concerned, again, we want to start with a shared set of best practices. So that allows us to use things like a base configuration for using customized, like in this case, to describe what are the common configurations that we might have across our application. And most applications, there's lots of similarities that we might have, so we want to share those best practices essentially. The second repository, the application code repository, that's where we're going to patch those configurations. So anything above and beyond those baseline configurations, that's where we're going to specify those. Things like the images or any additional port configuration or other application-specific configuration that we might have applied. Ultimately, that will render a fully hydrated manifest, again, that then gets stored within our environment repository, giving us that single source of truth. So that's the application workflow. What about the security workflow? Now, security workflow is all about policy management. So we can, of course, manage our underlying infrastructure, but the core responsibility of security in this context is managing the propagation of various policies. Those can be anything from pod security policies to firewall policies, anything that describes the behavior to essentially provide guardrails to application teams is what we define as a policy. Now, these are ultimately stored directly as Kubernetes objects and are handled by Anthos configuration management. So under the hood, Anthos configuration management is listening to that Git repository and allows our security teams in coordination with our operations teams and development teams to push those policies and configurations. ACM takes care of the rest, taking those configurations and propagating them across those clusters, allowing for full code review, continuous integration, and full integration into the development ecosystem. Now, to show us a little bit about how that works, I'm going to hand it over to Ben.
Thanks, Brandon. Let's take a look at the demo. Let's take a look at a couple of the workflows that Brandon was just describing in the CICD on Anthos presentation. So before we dig into the workflows, let's take a look at the GKE clusters that we have deployed and what we'll be using them for. So we have 4 clusters that we'll be using to run our applications. The first is a dev cluster. So in the demo, we'll use Scaffold to automatically detect the changes to the application code and then deploy them into the dev cluster. This will enable us to live test our changes on the dev cluster before we push them into the repository. From there, once they're pushed into the main line of the application code repository, a deployment is automatically kicked off, which deploys our changes to the staging cluster. Then, when we validated our changes on the staging cluster, we can merge the environment configuration from the staging branch into the mainline branch, which would trigger the production deployment to our 2 production clusters. The 5th cluster that we have out here is used for our shared services. So on that cluster, we're running GitLab, and that's where we'll be storing our source code and running our CICD pipelines. So now let's pretend that I'm an application developer, and I have a simple Go application. If we take a look at that, we see that it simply outputs hello world, and my task is to update that reading that's output from hello world to something else. So as a good developer, what we'll do is we'll start by creating a new branch. We'll call it new greeting. And before I start making changes here, I want to get Scaffold started so it's connected up to our development cluster. Let's first make sure that we're in the right context here. There we go. So Scaffold is going to watch our source code, and as it changes, it's automatically going to build new versions of the container, push them into artifact registry, and then run deployments on those of those new container images out to our development cluster, so that way we can test. So we can see here that Scaffold is up and running, and if we preview, we can see hello world is output. So now we're ready to get started with our changes. So we'll go to our editor here. So we're going to say, hello Google Cloud on air. So that'll be our new greeting. So we can see, as I change back to Cloud Shell, that Scaffold has detected that change and is already starting to rebuild the image. Okay, now the image has been deployed, so if we refresh in our browser, there's our new greeting, and that looks good, so we're ready to push our changes into our source control system and kick off the CICD pipelines. So let's stop Scaffold here. And we'll commit our changes, and then we'll push them out. Okay, so now if we go over into GitLab and we log in as the developer here, me in this case, okay, we can see that I just pushed a new branch, so let's go ahead and create a merge request. So at this point, what's happening is we're running a CI pipeline on our branch, and we are running tests. We're going to hydrate the manifests, and we're going to validate the manifests as well. So we're running a subset of the stages that we'll run later on. So everything except for the deployment part of the pipeline. So this is giving us the opportunity to validate any manifest changes that we might have made in the application code repository, as well as any application code changes. And we'll just have GitLab merge when it succeeds. Okay, so we can see through the comments here that everything is merged. So if we look at our CI/CD pipelines, we're now running another pipeline. So in this one, we're running tests again. We're going to build our new image, and we're going to hydrate and validate configs, and then we're going to push those configs into our environment repository. So while we wait for this to run, let's take a quick look at our repository and what we have in here. So in here we have our source code, so our main.go with our greeting. We have our Docker file, and then we have some Kubernetes manifests. So these manifests are the changes that we want to make. So in this case, we're setting the environment to dev for each environment. And if we look at staging or production, we can see that we're also setting the environment to prod. So these changes are getting merged together with the common shared best practices that are stored in this shared customized basis. So here's our shared basis, and this is a fuller manifest. So those environment settings are getting merged into this. And what the CI pipeline, the CI/CD pipeline is doing is it is going to commit those manifests, push those manifests into the staging branch here. So it's still running at this point. Okay, so our pipeline is now finished. So if we go and look at our environment repository in our staging branch, we can see that we just pushed new configs, both staging and production YAMLs. We hydrate them all at the same time so they're consistent. And see they are all fully hydrated manifests. So what that push did is that push triggered a pipeline to deploy those manifests to our staging Kubernetes cluster. And that's now done. So if we switch back to Cloud Shell, now we can see what we have running in our namespace, and our application is now running, and it's been running for 24 seconds. So we have deployed our changes to our staging cluster. Now we'll quickly promote those changes from the staging branch into the mainline branch, and that will trigger the production deployment. So we'll go in here, we'll make a new merge request. We'll merge those. If we take a quick peek at the changes here, we can see that all we really changed was the hash. But that merge request has now triggered the deployment to production. So we'll switch to our prod central context. And we can see that our new pods have been running for about 14 seconds. So our deployment to our production cluster is succeeding. Okay, now for the next workflow. As the developer, I've been talking with the Hipster Shop front-end team that they also have their application running on our cluster, and they would like to be able to connect to our Go application that we've been working with. So what we're going to do is we're going to switch over to the Anthos config management repository. So you can see here we have all of our namespaces and our cluster registries and that kind of stuff in there. So what we're going to do is we're going to make a quick change to our network policy to allow Hipster Shop front end to connect to our Go app. So first, before we get started here, let's take a quick look at our current network policies. So we can see that right here we have a just a default deny for anything that's not within our namespace. So, and what we're going to do is we're going to enable that for Hipster Shop, the Hipster Shop front end. So let's start again by creating a branch. And then we'll jump back over to our editor. And then here's our network policy that is sitting inside of our namespaces and our managed applications. So our Go app. So this policy is going to allow traffic from the Hipster front end to connect to our Go application. So we'll save that. Okay, and then let's push our change. Okay, so our change has been pushed. So if we jump back over to the GitLab UI here, what we'll see is we just pushed a new branch. So since I pushed that branch as the developer, I'm going to create a merge request. So we're going to allow traffic from the hipster front end. So we'll submit that merge request. Now, our policy has been set up such that I am not, as a developer, I'm not allowed to merge requests into the main line. So we're going to have to switch over to our network admin. So now I'm going to be our network administrator, and we'll review those policy changes so that way we can merge that request in and allow that traffic. And while we're doing that, you can see that we've kicked off another CI pipeline where we're verifying the changes that we're making to our configuration. So we're running CI on our Anthos configurations. Let's switch over. And we have a merge request here. So now I'm in as the network administrator, and we see the merge request here from me wanting to allow traffic from the hipster front end into our Go application. So while we were doing that, all of our tests pass. So let's quickly view our changes. So there's our changes that we made. They look good. So let's merge them. Okay. And now we're going to run CI on them again, just to make sure everything is still good. And when CI has finished, we'll be able to go out to our cluster and we'll see that this change has been applied. And we'll check it on both the production and staging cluster. Okay, CI is finished. So now if we jump back out to Cloud Shell and we look at our network policies again, now we see that we're allowing traffic from application hipster front end into our Go app namespace. So that process, as a developer, I needed to make a network policy change. I made the change in the Anthos configuration management repository, and then that change was reviewed and approved by a network administrator.
As we saw in the demo, we had several applications deployed across a number of clusters, both pre-production and production. Each application ran in their own namespace or their own little playground, so that way they ran in an isolated environment. In order to allow applications to communicate with each other, we had to involve the operations and security team, so that way we could update the network policies for those namespaces. And those policies and configurations were being managed using ACM, automatically being deployed and reconciled across all the clusters. Now, as a developer, they can focus on using a GitOps workflow. So developers can build new features and feature branches, and using tools like Scaffold, those changes can be automatically deployed to a development cluster so they can be live tested. When those changes are finished, a merge request is created, and when they're merged into the main line, the staging deployment is automatically triggered by the push of hydrated manifest into the staging branch of the environment repository. After those changes have been validated on the staging cluster, the operations team or the developer, depending on your workflow, can create a merge request to promote the configurations from the staging branch to the mainline branch. And when those changes are merged into the mainline, the deployment to production is automatically triggered. So using the principles that we described, you are now able to build upon a secure platform where you're creating and deploying your policy using Anthos Configuration Manager. You're storing that configuration as code, so you automatically get the tracking and traceability provided by Git. And as you saw in the demo, everything is highly automated, from the deployment of application changes all the way through the configuration changes that are tested and deployed using ACM. We're also using containers. So we're leveraging the immutable nature of containers to increase the reproducibility of our deployments and our infrastructure. And we're leveraging Anthos and Kubernetes as an open source standards-based infrastructure that you can then extend your infrastructure even further. Brandon and I would like to thank you for your time today.